Hello, welcome everyone. Lovely greetings to all the viewers. We are back again with another session of discussion. And the paper that we are taking today was asked on 3rd September 2020, the evening shift. Subject, of course, that's physics. Let us start. And the first question that has been placed from Thermodynamics. Now, what does this say? Let's try to understand. It's a very straightforward one. To raise the temperature of a certain mass by 50 degree, but you see the condition, that's a constant pressure. 160 calories of heat is required. So 160 under constant pressure condition. So here if I start with the equation, Q that is equals to NCP delta theta. Another, let's see, when the same mass of gas, that means the number of mole would be same, is cooled by 100, and you could see with the constant volume 240 calories of heat is released. So in that given case you would find 240 that is equal to, that's going to be NCV delta theta dash. The change in temperature is different in two different conditions, and based on this we got to calculate the value of degree of freedom. Let's say it's almost done here, and this one, if I divide these two equations, the first one comes as 2 by 3 and Cp by Cv, that's what gamma. The change in temperature, if you see, in case of constant pressure that was 50, and in case of volume constant that's 100. So that's going to be 1 by 2. In other words, the value of gamma that is equals to 4 by 3. And what is gamma? By definition, that's 1 plus 2 by F. So that gives the degree of freedom as 6. Let's go for the second question. The second question you could see, that's something related to the energy of a photon. There are two sources of light, and one emits X-rays of wavelength 1 nanometer, another a visible light of wavelength 500 nanometer. And it says that both the sources emit same power, 200 watt. And what are we supposed to calculate? The ratio of number density of photons of X-ray to that of the number density of photons of visible light. So here we can use the expression something like this, P equals to N times E, where N is the number of photons emitted per unit time, and that's going to be equals to N Hc by lambda. Now here what you need to understand is the power is same, and rest H and C that's also same. So straightforward, we can write Nx by N visible, that's going to be the wavelength of X-ray by the wavelength of visible. That's a very straightforward one. You could see N by lambda, that would be constant in this given condition. So now lambda x by lambda visible, that's what we need to do, and that is straightforward given 1 by 500. So where is the option? Option number 2, right? Let's go for the third question. The third question is related to simple harmonic motion, and little bit of conservation principle has to be applied as well. Very beautifully formed. There is a block of mass m, and that's performing simple harmonic oscillation. The amplitude is A. Now see, what happens is that when the block has passed through the mean position, exactly at that instant, half of the mass chips away, and we need to calculate the amplitude of the new oscillation, and that is in terms of Fa. We got to calculate that factor F. Now here the first and foremost thing is you need to understand, by the time when it reaches the equilibrium position, the situation is something like this. Now just say half of the mass chips away, but that would also take its own share of momentum, and by inertia the velocity would be exactly same. So this means the velocity of the remaining part will not change at that position of equilibrium. So if that's a condition, what we can say is that velocity at the mean position is omega times a. So in the first condition, that's a case. In the second condition, that will be the case. And what about omega? You know, that's equals to root of k by m, and this is the amplitude a. In the second case, because the mass has gone half, so that's going to be 2k by m and a2. Now you could see the value of a2 will be equals to a by root 2, and that comes as option number 1. Now let's see question number 4.